September last, Sayati from the College of Engineering and Technology for the Atal Faculty Development Program, technically and financially sponsored by Aicte Atal and organized by the Department of Mechanical Engineering, that is Polytechnic. A warm welcome to our today's esteemed resource person, Dr. Pranath Bendre sir. Welcome you, sir, in Sayati from the College of Engineering and Technology. He is the Associate Professor and Head of Computer Engineering Department of Pravara Rural Engineering College, Luri. He is awarded with PhD in 2018. Then he also worked as a resource person in various faculty development programs and also served as a paper setter in 2021 for his T subset. Then he taught various subjects at UG and PG levels. The UG subjects include the data analytics, machine learning, and resource methodology and also various UG levels. He also shared the responsibility of paper setter for 2021 pattern at T computer including various subjects. Also published various books and attend the conference at international and national levels also. So welcome you sir here and you all the entire family of Sayati. Welcome you sir for this faculty development. Can I request Nangre sir to felicitate Dr. Bendre sir. Sir, please come forward. I request Bendre sir to please come forward and just say a few words.
Good afternoon to all. First of all, I thank you, Rajuri team, because the second time I have invited here for Atal Fdp. Right? In last year also, I have attended this FDP on cloud computing, and this time the most important is regarding the machine learning and how the different AI strategies on that. Right? So my thanks to the team for inviting again me. This is a new technology, all of you know that, all faculty know that, what is AI, what is the back end of this AI. But it is important nowadays because AI is important, because without doing the AI, we can't do anything right now. So AI is important, how the backbone of this AI, that is important one. Means not we can directly imagine we are just listening various kinds of chat GPT, various kinds of app. But how it works at the back end, how X and Y works, that is important. Because if we know the statistics, if we know the mathematics, we know the basics about the math, then and then we can start the machine learning. Because without equations, without X and Y, we can't go for the machine learning, we can't go for the deep learning, then always we can't go for the AI also. So back end of these all things is the mathematics and statistics. So always we should know these kind of things. Many students mostly saying that what is use of mathematics. So I think the most important subject is the mathematics, because without mathematics we can't go such a kind of evaluation of the equations, and without equations we can't predict anything, because in machine learning or deep learning or any kind of algorithm there is always X and Y and various kinds of equations. These equations will help for classification of data, for clustering of data. Various kinds of algorithms are there. I think in 2-3 days you learn many things, right? And all algorithms are based on the mathematics. So the base is important, and then we can go for the various kinds of algorithms. So today I think my topic is pre-processing and feature selection and whatever feature engineering is this. So we'll start those all things. But before that, I thanks to the team for inviting me for this kind of Atal Fdp. So we'll start our sessions. There is no need of mic. Many faculties are there, and I can discuss two-way. Okay, there is a two-way communication between me and you. I think how many of you have learned the machine learning? फॅकल्टीना पण कोणतरी अभ्यास केलेला असेल. आहे का कोणी असं की ज्यांना मशीन लर्निंग शिकवलेलं आहे ॲज अ फॅकल्टी घेतलेला आहे? ओके. अँड स्टुडंट्स, यू नो द बेसिक्स अबाउट द मशीन लर्निंग? नो. आय थिंक इन 2, 3 or 4 days. I think 2, 3, 4 days. I am audible? Yes. Last. I am audible? Yes, I am audible. Okay. All of you know the machine learning. I am not discussing about the machine learning. I am directly focusing on the basic things. Those are important regarding this feature engineering, right? So see, everyone, every faculty discuss with you as a total structure of the machine learning. What is the machine learning, right? All of you know it is a one kind of different kind of algorithms. Those can be used for the classification of data and clustering of the data, right? So your topic or your FDP topic is related to AI. So AI is not totally dependent on the machine learning. The some part of the AI is the machine learning. Some additional part of the AI is the deep learning. More than that, there is a reinforcement learning. There is a neural network. The combination of these all things, then we can form one kind of AI, right? So these are the some basic subjects that comes in the where AI, right? These different subjects comes in the AI. So it starts with the machine learning, and the base for the machine learning is required the simple things, that is the equations, right? And the structure of machine learning is initially we require a set of data. Then we require the pre-processing methods on that, then actual algorithms, and then results. This is the steps that are come with any kind of algorithm in machine learning also, in deep learning also. So what kind of data is there, what kind of data sets are there, those data sets can easily compile, which can easily process, and any algorithm can apply on that, and then we can go for the visualization of the data, right? So see, simple, all of you know linear regression? I think no, linear regression, or in mathematics we can call it as a linear equation. All of you know, I think students know linear equation. What is that equation? Y is equal to mx plus c. This is a simple equation. If that is a linear equation. If it is a multivariable equation, then its meaning is there is a number of variable. If there is a single variable equation, then there is a one variable. Like these mathematical concepts are there. We are coming back to our point, but these are the important things. What is the variable and how those are important for the machine learning, right? So multivariable means there is a case, for example, y is equal to ax1 plus bx2 plus cx3, x1, x2, x3. Its meaning is that there is a multiple variables, right? And if there is only y is equal to mx plus c, its meaning there is only one x. So it's a single variable equation. For example, linear, similarly there is a polynomial equation, right? I think you know polynomial equation also. What is it? Y is equal to, yes, from student side, polynomial equation. Y is equal to, for example, ax plus x square plus bx cube, like this. Okay. In that also all of you know that there is a degree. In polynomial there is always a degree. Degree 1, degree 2, degree 3, like this. At degree 10, 20 like this. Okay. So in that polynomial also, see, in multivariable equation, y is equal to ax1 plus bx2. Two variables are there, right? But in polynomial, there is only one variable. There is only one variable. What is equation? Y is equal to ax plus bx square. X is the same. There is no x1, x2. Keep in mind. There is no x1 and x2. Variable is fixed. Then again c x cube. Then d x raised to 4. Like this. Means that equation is having the only one x. Right? And the main part of the machine learning is that x. Main part of the machine learning is that x, because see, for example, I am writing equation like this: y is equal to 3x plus 2. Simple equation. Y is equal to 3x plus 2, and this equation is act as a one kind of equation that will predict the y. How it is possible? For example, if there is a x value is a 1, what is value of y? Keep in mind what is the equation first. Y is equal to 3x plus 2, 5, right? Now x is equal to 2. What is y? Kiti? 8, right? If x is equal to 3, 11. X is equal to 4. Okay, whatever values, right? Means there is a something values that are predicted by using the equation. We are just putting a particular value in that, and that equation is act as a predictive equation. So in mathematics, in statistics, it called as a linear equation, and in machine learning, it called as a linear regression, because that equation is useful for the predicting the future values. So here in this equation, we are predicting the future values by putting the some x values, right? So whatever x may be a 1, 2, 3, 4, or it may be a something different. For example, that x may be a sugar level. That x may be a sugar level, and our prediction is diabetes is present or not. Right? So this is a problem. For example, classification of the data, and in that we have to predict the patient having the diabetes, yes or no. That is the problem, right? In that cases, what we require? We require x. If we have the x, according to that, we can easily predict the y. So x is a one component and y is also one component, and always in machine learning it called as a dependent component and independent component. Right? Because we have to learn this x and y, and that x and y is nothing but the feature engineering. That x and y is nothing but the feature engineering. So for example, we know patient, right? Patient having the various kinds of attributes, or we can call it as a various kinds of data. Means name of the patient, right? Its address, its age, its gender. Again, these are the common things. Again, there may be a, for example, blood group of patient, then diabetes like sugar level is there, maybe a temperature is there, maybe a something, various kinds of fields are there. We can call it as a fields initially. And these fields are important for the predictions of the results. Means that patient having the cancer, that patient having the something COVID like this. We require the basic parameters. We can call it as a parameters, and these parameters are nothing but the features. These parameters are nothing but the features, and the final result is depend on these parameters. Right? Means for example, one more example. For example, today temperature is something 20, right? 20, 22. tomorrow temperature is something 23. Then one day after there may be a 24 like this. Okay. So you can directly assume that there may be possibility after 2 days temperature may be a near about 24 or 25. How we assume this? By just doing the calculations, right? Means there is a one sequence, and by using that sequence, we have calculated the temperature, right? So it may be possible temperature is a one x variable. Temperature is a one x variable, and we have predicted again same x variable. There is a two cases: predictions of the x and predictions of the y, right? So in this case we are predicting the same thing, we can call it as a prediction of the same variable, and it may be possible the combination of various things. Means for example temperature is there, humidity is there, some environmental conditions are there, there may be something a different parameter is there. By combining that we can say that today rainfall is happen or not, like this, right? So whatever decision is there, that decision is taken by using the sum of the data, and this data means, for example, this temperature we can denote it as x1, something humidity we can denote it as x2, something environmental parameter we can denote it as x3, right? So x1, x2, x3, these three are the something independent variables. These are the independent variables, and by using this x1, x2, x3, we are predicting the actually y variable, and that is the dependent variable. And that y variable is actually the decision. That is actual decision. So equation may be like this. For example, y is equal to something 3x1 plus 4x2 plus something 10x3. So just putting these values means, for example, temperature value of x, something x2 value as a humidity, and something different value, it will be forecast the rainfall. Like this, we should know the basics about the different values, that is x and y, right? So initially we see that a patient having the number of features, name, minimum, right? But there always a dependency of the variable and independency of the variable. Means for example, that particular patient having the diabetes, that diabetes is dependent on its name? No, right? On its age? Yes, maybe. We can say maybe. For example, its gender type? Yes. Maybe or may not be, right? But sugar level? Yes, it's totally dependent. So these variables dependency is important. On which variable it is important and on which variable it is not important. So there is a set of variables, right? We can say that there is a set of features. Variables nothing but the features. So selection of the feature is important. So there is a part selection of the features. Means we can't select directly all features to predict something. We have to select the best features. Those features can be useful for predicting something. Means for example, for patient, there may be for predicting the COVID, we require something different features. For predicting cancer, we require something different features. Predicting diabetes, we require something different features, right? So feature selection is one of the important topic in feature engineering also. Feature engineering, the basic things is you know the features first. What is the feature set, right? And selection of the feature from that number of features, right? I think you learn about the principal component analysis also. What is the principal component? That PC algorithm is there. That is one of the algorithm that can be used for the selection of the features, right? So feature selection is important because if we select the best features, then we can go for the best results, right? See, there are 4 steps. First one is the data pre-processing, then In pre-processing we can do the feature extraction and these all things, then main algorithms and then results, right? So we are in just pre-processing, we are not applying any algorithm today, we are just discussing about the pre-processing and feature engineering, right? The next part is the whatever different algorithms are there. So whatever data, how data is prepared, that is the part of feature engineering, right? So there may be a handling of the missing values, there may be a handling of the something garbage values, there may be a handling of the something encoding and decoding values. Like these initial steps are required. Why required? That is also important, right? Because for example, see in machine learning, for example, sir want to apply one algorithm on one data set. All of you know data set, right? We can't directly apply algorithm on a data set. It's not possible. Whatever data we have, and I just know the SVM is there, CNN is there, new wires is there, and I want to select SVM and directly apply on that algorithm. Anyone say that SVM is a very good algorithm, just select that algorithm, apply on data. This is not good thing about the selection of the model also. Similarly, selection of the feature is also important. Selection of the model is one part, right? That is also important. See, so this is not step. Directly we can directly apply the algorithms. So initial stage is what? For example, if data is like this, see, 1, 2, 3, 4, 5, 6. This is a data pattern. All of you know data pattern. What kind of algorithm is suitable for this data? Yes. Yes, any, if no. If data is a simple one, 1, 2, 3, 4, 5, right? We can directly say that next element is 6, after that is a 7, after that is 8. We can directly say because we know the data pattern, right? But what kind of algorithm is important for this? We can't apply directly SVM. It's not give the good results. You can't apply the new device. It can't give the good results, right? So important is what? Data visualization is the first part in the selection of the algorithm. So you should know the structure of the data. We should know the structure of the data, and that can be done by using the visualization, right? So whatever data we have, we should know the structure. So for example, 1, 2, 3, 4. This is just in a increasing order. Means for example, this is a y and this is a x-axis, right? This is a y, this is a x-axis, and data is something 1, 2, 3, 4, 5 like this, right? So whatever data is there, it is in a one line, right? So in this case, if we apply a linear regression model, which one? Linear regression, it gives 100% results to you. You can't apply the another model in that cases. So you should know the what kind of data is there. That data analysis is important. I think you learn data cleaning and these all methods. Those are the methods, right? But data analysis is also important. Now, for example, same thing I have just discussed about the linear one, right? Now see, there is a y-axis again and there is a x-axis. Just take a point where morning temperature is what? Something 20, okay? Then afternoon temperature is 25, right? Then evening temperature is something, we can say that 23. Then night temperature is something 20, near about 20 or 18. Then again morning temperature is something 20. Then afternoon temperature is 25. See this pattern, right? This is a pattern. You should know the pattern of the data, and if we know the pattern, then we can easily apply the model. So this is a pattern of the polynomial regression with a degree 3. With a degree 3. If we apply a polynomial regression with a degree 3 in this case, in that cases you get the better results, right? If we apply something linear equation in this case, what happens? Linear equation is a straight line, but pattern is something different. So there is a no fitting of the data. What happens? Always there is a calculation of the results, and that results are calculated by actual data and predicted data. So whatever data is there, actual data is 1, 2, 3, 4, 5 in linear equation, right? And if line equation is the same, always it predicts the correct results, right? But if actual data is in this pattern and predicted result in this pattern, always that line predicts the future values as a linear fashion. So actual values is something different in the pattern and predicted values is something different in the line. So there is a huge gap between the actual data and predicted data. So it's a one kind of gap, and we can call it as there is a error in the prediction and actual data, right? So it is important to analyze the data first. Analyze the data first, right? So that data maybe creates the problems also. Data creates the problems also. We see same things are there. Data is 1, 2, 3, 4, 5. This is simple example, but we can easily understand with the machine learning, right? So if we write the equation for this, y is equal to 3x plus 2, by default it will be predicted whatever values are there. So if 1, 2, 3, 4, 5, what is the equation of this data? Anyone? X plus 1
X plus 2x plus 3x square plus 4x cube n square.
See, for example, simple. If x is equal to 1, y is 1, then equation is y is equal to x. If x is equal to 2, y is equal to 2, then equation is same, y is equal to x, right? Now see, for example, x is equal to 1, y is a 2. X is a 2, y is a 4. X is a 3, y is a something 6. What is equation?
Y is equal to 2x.
Y is equal to
X square.
y is equal to 2x, right? That is the correct one. Y is equal to 2x. How that is the correct? Put x value in that. For example, x is a 1, y is a 2. 2, right? If x is a 2, 2 into 2, 4, y is a 4. If x is equal to 3, y is always 6 into 2. Sorry, 3 into 2, 6. Means that pattern matches, right? And this is the equation that is generated from the data, right? Now this equation can easily predict any kind of data that lies in that equation. Okay, so this is a simple thing, right? Now something equation is different, maybe, right? See, in this case, which x is equal to y is equal to 2x. In this case, results are 100% correct. Correct results are there because whatever x value correctly predicts the y value. Correctly predicts. So see, before that, you should know the labels and unlabels. I think all of you know, if in last 2-3 lectures you heard about the labels and unlabels, because supervised learning there is always a label is present in supervised learning, and in unsupervised learning there is a no labels. There is a no labels, right? Labels means what? There is a one column, we can call it as a y, and that values are present. It's meaning that is a classification problem. Always see, if there is a y and their values are present, then it's a problem of classification, and if those values are not present, then it's a problem of clustering. So all of you should know how to identify the which kind of algorithm to be applied. That is also one of the important thing. What kind of algorithm is to be applied according to the just availability of y, right? That is the one component, right? Visualization is one of the method. According to that also, we can easily apply the model, right? So In this case, same thing. We are taken example as C, X 1, 2, 3, 4, 5. Y as a 2, 4, 6, 8, 10. This is available data set. This is a available data set, right? And we have to apply a model on this. How machine learning works? All of you know that 80% data is used for the training and 20% is for the testing. That is also part of the pre-processing to split the data set. Splitting of the data set is also part of the pre-processing, right? Because we have not applied a model on that. So what kind of different operations, actions, methods apply on data before applying the model is called as a pre-processing. Before applying the model, we have not applied any model. We are working with the data, and that is a part of feature engineering. That is a part of pre-processing, right? So whatever data is there, in that splitting of the data is also important. Training and testing, right? If problem is a classification, then in that cases we can do the training and testing. If there is a no, we can't go for the training and testing data sets, right? That can be done with 80% and 20%. We will see in slides also. See, for example, data is there, right? We have taken an example as a 1, 2, 3, 4 and its related y values, correct? Now this is a data set and we have to do predictions, right? And in these predictions, now I am saying that x is a 6, question mark as a y. We have to predict that value, right? See, in data set there is a two column, x and y. X is a one of the variable, that is a independent variable. Y is a one of the variable, it is a dependent variable, because y values is always depend on x values. If x value changes, y value changes, so it's depend. Like these concepts are there, right? So initially 5 values, y 5 values, right? Now question is, if for example x is a 6, what is value of y? Always 12, right? How we have calculated? We have calculated with the sequence only, but actually mathematically it is calculated by using y is equal to 2x, right? That is an equation, that is a predictive equation. We can call it as a predictive equation. We can put any x value in that, it correctly use the y value, right? So these kind of examples are using, for example, stock market, right? We see that like these curves are there, right? In stock market, whatever curves are there, so histological data, whatever histological data, that data can be used for the predicting the future values. But we require the equation. We require the equation is nothing but we require the model. We can call it as a model. So in machine learning, if we go for the new there is a no in something, there is also one equation. If we go for the linear or polynomial, there is always equation, right? If we go for the SVM, there is always equation, right? So that equation is important, and that equation will produce the future values. We are coming to back our data set. We can easily predict the future values, right? Now see, simple thing, x1, 2, 3, 4, 5 and something 2, 4 and in next value is not present in the database. Means 2 is there, 4 is there, 6 is not there, 8 is there and 10 is there. Correct? One of the value is missed in the data set, and if value is not present in the data set, it creates the problems. That algorithm not predict correct results because that value is already missed. How? I will say how that is possible. See, whatever data set is there, all of you know in linear regression there is a one concept, slope and intercept. I think no, slope and intercept, right? Slope is one value and intercept is one value. Means for example, this is a x and y axis, right? whatever linear line is there, there is a something like this structure, we can call it as a slope, and the line interact with the y-axis, it is a one kind of intercept, right? And these values are evaluated with standard formulas, and if we evaluate these values, we can put these values in a equation. So that equation may be like this: y is equal to something 3s plus 2, like this. That 3 is a one kind of slope and 2 is a intercept. That values are generated by using the data set, right? And if we put down those values in equation, that is the predictive equation, right? So that values are evaluated with help of initial x and y values. How that are evaluated? With initial x and y values. And if in the data set particular value is not present, it's meaning that evaluated values are the different. That evaluated values are the different, and if values are different, always that equation not predict the correct values. It means, for example, y is equal to 2x. This is the equation. Now the value is not present, so in that cases equation is something y is equal to 1.5x, because of value is not present, and now that equation not correctly predicting the future values. Now for example, x is a 6. What is the value of y? 6 into 1.5 something, right? So that is not accurate value, and that can be done by using simply the missing value. So in pre-processing, the handling of missing value is also important. Handling of the missing value, right? So these kind of various kinds of important things are there in the pre-processing part, in the feature selection, in the model selection, and by using that we can then go for the selection of the model. So like this, pre-processing or pre-engineering, we can call it as something future engineering, that is important part in the machine learning. It is also important in the deep learning, right? So this feature engineering, how these features are selected, how these features are useful, and why these features are too much important in the machine learning, right? So this part is important, and then we can go for the selection of the model, right? So for example, like this, I just told one example about the temperature, right? That is like this, okay? In same thing, in that if data is not present, it not correctly predict the future values. So this is the important steps. Data should be present, selection of the important features, and then we can go for the selection of the model. So we just overlook one by one these important things, and we will also discuss what are the important part in that. All of you know, I think this supervised learning and supervised learning, you learn about these things. Important is what? That label part. Labels are present in supervised learning and not present in unsupervised learning. There is always two type of data machine learning can handle. I think many students may say that, can I apply a machine learning algorithm on image? It's not possible. It's not possible. Machine learning can handle only two types of data: numerical data and categorical data. If we have to go for the image processing, whatever is, for example, something images of the X-ray images, or there may be some CT scan images, we can't go directly applying the machine learning algorithms on that. In that cases, we can go for something basic image processing first. We have to extract features. Those features are in a numerical form, and then we can apply the machine learning algorithm on that, right? That is a part. In CNN is a part of the deep learning, right? So CNN is a combination of feature extraction and classification. Here, what happen in machine learning, we have to always apply a direct classification algorithm on data. It is possible in machine learning, but in deep learning, we can use the feature extraction plus classification together in the CNN. But here, feature extraction is a part of the feature engineering, that is a different part, and then whatever results of that feature extraction, we can apply the classification algorithm on that. Like these steps are there. So whatever data, that data is important, and if labels are present, then we can directly go for the classification, and if not present, then we can go for the clustering algorithms. So this is the basic things for the selection of the model, right? So machine learning handles only two types of data, categorical and numerical data. So categorical means there may be a something, we can say that yes, no. There may be a something, for example, class is something, we can say that cat, dog, like this also. There may be a something, there is a something character types or keyword types data. And numerical means 1, 2, 3, 4, whatever numericals are there, that is a one kind. So such two types of data can be handled by the machine learning. But before that, if data is yes, for example, yes, right, and no, means see, brain tumor is present or not. This is the situation, right? So what kind of data is there? X is there, x1 is there, x2 is there, x3 is there, dot something more parameters, and lastly y is there. Okay, so this is a table containing x1, x2, x3, and lastly y. So x1 is something, for example, size of the X-ray image, and in that something whatever extracted feature is there. We can say that that feature is something 20 value, then something 30 value, something 45 value. So these values denotes something the size of circle, for example. So according to that, y value is yes, means brain tumor is present. Always there is a data set. If y is present, it's meaning that data set is already classified. All of you know these things, right? Data set is already classified. We have to predict the future things, right? So it's meaning patient 1, x1, x2, x3 is present, y is present, yes. Patient 2, x1, x2, x3 something value, y is a no. Patient 3, x1, x2 present, yes, no, yes, no, yes, yes, like this. Its meaning is simply that data set containing various kinds of patients' data with x1, x2 having the some values, and that values are nothing but actually the feature values, and according to that tumor is present or not present, like this. That is a classified data set, already classified data set. So this is a one kind of data set where yes, no, yes, no, yes, no is a present, right? What we have to do? We have to do new patient is coming. We are checking its x value, its x2 value, its x3 value, and whatever values is there, we have to apply a model on this initial data set. Model is something y is equal to something x square, like this model is there. We are putting these new x values in that model. It directly predicts yes or no, brain tumor is present or no, right? So this is a classified data. In that, this x1, x2, x3 are the important parts, right? So this yes is a word, yes, no, no is a word, right? So in machine learning library, all of you know, I think sklearn is an important library in the Python. By using that, we can do the machine learning programs. sklearn is one of the library, right? There is maybe a TensorFlow, there may be various kinds of libraries, those can be used for the handling the different kind of algorithms of the machine learning, right? You can use Veka also, you can use MATLAB also, various tools are available, but mostly in Python, sklearn library is there. By using that, we can simply execute the programs. Means see, program how machine learning is simple. In mathematically, if we go for the machine learning, we require the x, y equation, put the values like this. But if we go in the sklearn, there is only one model. Its name is linear regression. Just write that model name, put x and y, x train and y train values for that. It directly gives you results, right? Means programmatically machine learning is too much simple, but we should know how it works. How it works means that is 1, 2, 3, 4, and how next value is predicted. That is the important part in that, right? So S is there, Y, E, S, coming back to our point, yes and no. System can't handle yes and no. right? So in machine learning, pre-processing, there is some kind of encoders are there. Encoders are there, means encoding functions are there. Like linear regression, there is a model linear regression. For Naive Bayes, there is just a Naive Bayes algorithm. For SVM, there is a linear SVM, kernel SVM. Like these functions are there. By using that, we can easily apply a model on a data set, right? But important is what? Pre-processing of the data, right? That in that pre-processing, if in the data set there is a brain tumor is yes, no, yes, no, yes, no, like these keywords or categories are there. So in that cases, we require the encoding of the data. So in sklearn, there are some standard encoders. By using that, we can easily convert this data into numerical, and then various kinds of function easily handle this kind of data, right? So encoding, decoding this part is also important. Normalization is important, scaling is important, cleaning is important. These various kinds of basic things, those are important in pre-processing of the data, right? So this is a part of the pre-processing where we can work with the data before applying the model. Then we can go for the various kinds of model. Just we see in fast. Don't take attention. We will conclude within time. All of you know this diagram. That is important. Why? Before machine learning, whatever algorithms are there, we have to do the feature engineering. Our topic is feature engineering, so we are focusing on that. We can do or we can work on any type or any kind of models, right? So see, this feature extraction is important. You can go for the next slide. See, whatever data set is there, I am saying like this, whatever data set is there, we have to mine the important one, because that diabetes is only depend on the sugar level. So whatever points are there, we can go for the important from that, right? So whatever data is there, we have to mine the important from that. So whatever data is there, and that data we can call it as important data, we can call it as features. That important one is the features, right? So different characteristics are there, features are there, variables are there, many things are there. So these features are nothing but the x and y. In mathematically we can call it as x and y, right? So for example, this is a simple example. It contains the different kind of x values, and there is a one y values is there. That y is nothing but the label. If that value is present, then it's a problem of classification, and if that value is not present, then it's a clustering. So that value may be any kind of value. All of you know that if you work on the data sets, it contains various kinds of columns and various kinds of rows, and the last column is a one kind of a classification, that of y1, and we have to always predict that one. If that is already present, we can do for the training and testing of the data sets. So there are many important steps regarding this feature engineering. We will discuss one by one. Those are the important. All of you know this: transformation, cleaning, and these all things. Next, see, in feature engineering, whatever data is there, right? Means, for example, if there is a problem of all of you know that rainfall sensors, or we can call it as loggers, data loggers. In that data loggers, they are continuously collecting the data from various sources, whatever sources are there. But we have to find the important from that. We can call it as a raw data, whatever data is there. We have to mine the important from that. That is a part of feature selection. Then we can apply that for the different algorithms, and we can find the different insights from that, right? See, this is one of the example. Whatever data are there, means for example, image is there. All of you know image data set. How it works? What is the major size or simple size of the image? Any size of the image? Pixel size? You know. In pixels, tell me in pixels, size of the image. हे काय हे नाही बरं का, मी टीचर आहे तुम्ही टीचर आहे, त्याचा काय हे नाही करू, फक्त एक जनरली आपल्याला माहीत असावं काय असते. काय असते सर? आपल्या मॉनिटरची साईज काय असते? 10 चुकली तरी चालेल, 1000 इंटू आपण असं म्हणू 800. बघा, इट्स डिपेंड ऑन द व्हॉट एव्हर साईज ऑफ मॉनिटर, राईट? इट्स व्हेरी अकॉर्डिंग टू दॅट. It's also vary according to the mobile also. What is the size of mobile? According to that, it captures the pictures. Okay. So that image size is, for example, pixel size 1000 into 800. For example, its meaning is what? 1000. We can say that rows are there and 800 columns are there. Image. One image is there. And its size is 1000 into 800. Its meaning is what? It's a pixel size. तर आपण काय म्हणतो? Pixel size. One pixel is nothing but one LED in the monitor. One LED in the monitor, right? And that LED gives 3 values, RGB. आपल्या तिकडे नाही जायचं, तो खूप मोठा टॉपिक आहे, पण आपल्याला आपल्या पॉइंटवर यायचंय. RGB, right? All of you know RGB, right? Its meaning that values may be changes. It may be something that values are lies in between 1 to 255. Always that values are lies in between 1 to 255, right? So that value may be a 200. Something G value may be a 100. Something B value is a something 220. It shows a one unique color. If this is a combination. The combination changes. For example, now R value is something 50, G value is something 20, then something last B value is something 31. Its combination color is something different, right? Means according to this value, that particular LED glows. Okay, this is the basic. Okay, now the image having the how many pixels? 1000 into 800 means how many pixels? Just calculate, it's a mathematical. Something 8 lakh, I think. Okay, or maybe 80 lakh, whatever. How many LEDs are present there? Same. How many pixels are there? So how many LEDs are there? 8 lakh LEDs are there. So for example, I am capturing this image. It contains different kind of colors, right? Many where it's the same color. For example, that white. Anywhere, many things, many pixels showing the one color, that is something wall color. Okay, and another colors are these names, images, and all these things. Okay, its meaning that particular pixel lights according to these colors, according to these colors, right? See, simply we are coming to our point as a feature engineering. Okay, and this is the image, and always we are saying that we have to extract the features from image. We have to extract the features from image because our aim is to find the brain tumor is present or not. And how brain tumor is detected? If there is a something circle in the image, right? If that circle is present, then that algorithm shows that, or maybe a result that brain tumor is present or not. Like this, for example, how many girls and how many boys are there? We have to extract something from the image, and then we can calculate those values, right? So we have to extract these things, means we have to do something operation on that image, right? We have to do some operation on that image, and that image is at the back end is stored in the format of matrices. In the format of matrix. So we have to multiply with the different matrix, so it gives something result, right? Means simply, for example, there is a matrix 4 by 4 and in the center there is a one value. Its meaning is in that image there is a one dot is present, for example, right? We have to detect that one. We have to apply a particular matrix, another matrix, multiply with that, it shows a one result, it contains only one that dot. like this. So whatever results are there, whatever tables are there, we have to minimize those tables one by one, one by one, one by one, and we have to extract important from that. That is a part of the CNN. I think you heard various kind of convolutional layers are there in CNN, so that will minimize these all whole data set, because that is not useful, and we have to extract the important one. That can be done by using the deep learning, right? So in machine learning, this can't be handled, right? Images can't be handled. Machine learning directly uses the whatever data set is there by using that. All of you know this site. If you know, and if anyone is a researcher, you can use this Kaggle site containing the various kinds of data sets. Various kinds of data sets are present on this site. You can just download it, you can just upload it. Colab also, Google Colab you can use, or you can use the Jupyter, Python, sklearn library. Just upload it and show what kind of X values are present in that, what kind of Y values are present in that. Means all of you know that it is not limited to computer engineering, right? Now in healthcare, in medical, in mechanical, in civil also, in for example, if civil faculty are there in civil faculty, I think no, right? I am working with civil faculty data set also. They are having the various kinds of blocks in the civil, right? And they are checking the strength of that blocks with different temperatures, strength of that blocks, right? So they having the data set x1, x2, x3, whatever. Means for example, they vary the temperature, they checking the strength of blocks with different conditions. We are just applying the machine learning model on that and predicting that particular block is sustainable or not, like this. Means anywhere we can use the machine learning algorithms, right? So similarly, various kinds of data set easily available on the this Kaggle. Okay, there is one more site. If anyone is a researcher, data.gov. That is one of the site. By using that, we can easily download the various kinds of data set. There is a major problem availability of the data set. What kind of research you can do, or whatever research if you start, there is a major problem with the data sets. And this is a not situation. What happened many times I heard about, many faculties or researchers say that I am using the SVM, I am using this kind of hybrid model, I am using this kind of SVM model. And if I ask what is data set, they say that I have not downloaded data set. And initially I told that if you know the structure of data set, you can't go for the selection of the model. So this is important. Whatever data set, first find it, download it, just find out its structure, and then you can start by applying the various kinds of model. So first step is a data requirement, data gathering. That is one of the part, right? And then analyze that data and then apply the model. We can't go directly the models. So these are the various data sets. You can just Google out it. You can download these all kind of data sets. See, and simple equations in the sklearn. By using that, we can do the pre-processing. Means see, simply that kind of sklearn library, sklearn data sets. These are the functions. By using that, you can easily access these data sets in your Python library, and you can do operations on that. Means that first two sentences are important. By using that, next activity. That load booster is a data set. Just load, we can easily load in the Python. Means doing such a kind of machine learning programming is a simple part. It's not a difficult thing. But many say that it is too much difficult. Machine learning, deep learning is not difficult. It's some 10 to 10 line equations. By using, you can easily do your research. Just load data set, apply model, and whatever results, we have to predict them. It may be estimators are there, various kinds of estimators. But checking of the accuracy is important in that. Always we have to check the accuracy and whatever accuracy is there, if it is low, then re-again train the model. If something accuracy is something increasing, retrain, this kind of concepts are there, right? So that is the important part, and you can download and use these kinds of, see, X and Y is important in that. See, whatever data set is, that always stored in a X and Y, because always we have to predict the Y. So data set first X values, whatever x1, x2, x3, put in X, and whatever label is that put in a Y. Because this is a start process, we can start with these things, right? So there may be a whatever concepts are there. If you know the overfitting, if we know the efficiency, these are theoretical concepts. But we will see what is that also. Next. See, there is a one problem in the data. झोपेचं नाही बरं कोणीच. झोपेल नाही कोणी बोलतोय थोडं चेंज म्हणा. There is a one problem, underfitting and overfitting. If you know underfitting and overfitting, there is also one thing that there may be always a in between that something we say that average fitting. Okay, overfitting is what? Data covers all points. Underfitting means we see that example. If data nature is like this and we are using the linear model, right? Actually, this is another topic. We require 2 hours for that, right? So we are not focusing on that, but that is a problem. That is initial problem, and by using that, we can analyze the data, right? So see, this is the initial part. This is a feature engineering. Whatever X and Y are there, we require to convert that data into training and testings, and always that data is a 50% or maybe a something 80%, maybe a 20%. It's depend on you how to that data is selected. So like this data set we have just discussed about x1, x2, x3 and y. This is the data we have seen 1, 2, 3, 4, 5, right? So always first 4 records as 80% you put in a training data set, and last 2 data points means for example 5th and 6th record always put in a testing data set. Why that is? That is a part of the estimations, that is lastly used, right? After applying the model, we have to test the data set, in that cases is required. So that data set and how that data set is converted, because this is also one of the important steps in machine learning. Because always for any kind of machine learning algorithm, we have to give the input, right? And these inputs are nothing but x and y always, right? So this is a part splitting of the data set, and this is a simple method in sklearn. By using that, you can easily split the data set. This is a I think equation: x train, x test, y train, y test, and this is a train, test, split. Train, test, split. What to split? X and y. What is that test size? Is 0.25. It means 25%. Like this is too much simple in programming, but we should know the sequence, because we have to train the model, and how that model is trained depending upon the existing data, right? And if model is ready, then it can be tested with existing data. Is it correctly predicting or not? Like this, okay? And then we can use the new data set if that model classifies the correctly. Like these steps are there, right? So this splitting and this kind of data set is important, but this can be done with the classifications algorithms only, okay? So managing of categorical data, I just initially told that machine learning handles only 2 types of data set, categorical and numerical data, right? So this is the one kind of categorical data set. Whatever categorical data in text format, we require convert it into numerical data set, right? This, for example, this is a next. For example, see, this is a data set having the number of categories, means labels, we can call it as a words, okay? Next. This is also one of the example. Means depending upon various kind of conditions, we have to play something or not to play, right? Means for example, outlook is something, temperature is something, humidity is something, and we have to take a decision. Initially, we have discussed these things, x1 and y. Y means in this case, play tennis, yes or no. This is a y, and that kind of decision is taken from these different x values. This outlook, day, outlook, temperature, humidity, wind are the x parameters, and last one is the y parameters. So depending upon these x parameters, y is already in that. So according to this data set, we have to check, we have to do. These are the important, these are the categorical data. We are focusing on the pre-processing. We are not focusing on any kind of algorithms, right? We can't go for the algorithms because we know that for this we can go for the Newey Bayes algorithm. Okay. So this kind of data is here, we require some kind of encoding, right? So this kind of different, for example, this is a one data, this is a simple encoding. We have converted that data into something different format. Next. See, this kind of equations are there. By using that, we can easily convert the categorical data into numerical data. So whatever data is there, by using simple, next there is one equation. See, label encoder. This is the one kind of function in SQL library. By using that, we can easily convert categorical data into numerical data. So these kind of statements may appear in your program before starting the algorithm. So this is a part of pre-processing. We require conversion of these things. So this is also one of the things. Next. But see, this is the managing the missing features. We just told about that example. If value is not present, it creates the problems or predicting the future values. So handling of these values are also important. This is a part of future engineering, right? And if we handle this kind of data sets by using different methods, then we can go further applying the models. So this is also one of the important part. But how it can be done? See, for example, it can be done by removing the whole line. Or it can be create a submodel, or it can be by something automatic strategy. See, we are focusing on these 3 points. These are the important in the data set. See, for example, data set is there. If something value is missing, if we remove that one, it's not too much of it. But if as it is present in the data set, it creates the problem, right? So one of the steps is to remove, means to handle the missing value. There is no value in that. Okay. It may be possible, for example, temperature values are there, right? Again, in the morning 20, after 1 minute 20, after 2 minutes it's a 20, after 3 minutes something 20.1 like this. Okay. And now up to 12 noon, these values are something 25. So this is a graph like this. Okay. After that it may be like this, then again like this. Okay. So in this situation, if one value is missing, that not affects overall things. So situation depending upon the data situation, we have to take a decision, right? But if data is like this, for example, morning, then afternoon, then again evening, in that cases, if something missing, it creates the problem. If you remove that line also, it creates the problems. But if data is something per second, per minute, and if we remove that one, it's not affecting the future results, because you always learn, or what you always focus on the future results. So handling of these parameters are the important. So removing is one of the, you can create a submodel. Means for example, values are like this: 20, 20, 20, 20, 20.1, 20.2, 20.3. Then there is a missing value. Okay. By using this, you can apply a model and predict that one. This is situation. This can be done. This is actual things that work with the machine learning. So by using that also, or there may be a possibilities. Just take a next value, just take a previous value, just do the average and put that values, average value. That is also one of the things. So any way or different way you can handle these things, right? So that is the important things in the handling the missing values. Next. So see, this is one of the class, imputer class is there. Imputer is one of the class. By using that, you can handle the missing values. So this is a part of pre-processing. This is a part of pre-processing. For example, if situation is that temperature, in that case, if there is a miss 2, 3, 4 value, there is no issue. But if the situation is, for example, patient's something brain tumor data, there is a difficulty. If we remove that, if we apply model that and it predicts something different, in that case situation is different. So according to data, we have to take a decision what kind of model is applied, if remove or it may be replace that data. Because those all things are the important, and by using that we can go for the future things. So imputer is one of the, we say that a function, and there is a one in that C, mean. You heard about that mean? Mean means what? Taking the average. We can see that simply in the average. That is one of the part, mean, mode, max, like this. That is also important in machine learning. That is a part of statistics. Okay. But that mean, its meaning is we have applied a mean strategy by using imputer class to handle that misvalue. So this is a part of pre-processing, right? You can use any method in that any miss value is not available. Many things are there, but handling of that is important. Next. See, here is a median, something like that. Next. Similarly, data scaling is there, data normalization is there, many more methods, those all are related to the pre-processing. Next. This is right. Scaling is important. Why? See, तुम्हाला कळेल लगेच मी एकच मिनिटात सांगतो. See, for example, x is 1, 2, 3, 4, 5. X is 1, 2, 3, 4, 5. And y is something 2 lakh, 5 lakh, 7 lakh, 8 lakh, 9 lakh, these values. And if you try to visualize the data, x is something like this, that x and y is something too much high. We can't find the values how it will be visualized. So in that cases, we require the scaling of the data set. Means users divide that different y values with the 1 lakh. So that values are now something 2, 4, 7, 9 like this. Because that are in lakh. And if we divide into lakh, it's 1, 2, 3, 4. Now that scale is something match with x and y, and we can easily find the pattern between x and y. Always we have to find the pattern. If we know the pattern, then we can apply the model. So scaling is important part in that also. Next. There is some standard scalars, those are used in a scalar library. By using that, we can do these things. Next. Normalization is there. Next. All of you know why normalization is there. Normalization means whatever data set are there, we have to find the simple features. By using that features, we can predict the important things. In database management, there is a first normal form, second normal form. You heard about this. Means whatever feature set is there, select something important, prepare one table. Like this normalization concept are there, those are also important in feature engineering. Because if we have the data set, and we have our aim is to find the patient is COVID positive or not. We require only 1, 2, 3 parameters, not all parameters of the patients. So data normalization is a one thing. We require y. Y means what? Where values are present, COVID is present or not. There may be a y2 that shows something brain tumor is present, because we know that that particular patient may having the brain tumor or may having the COVID or may having something sugar. So y1, y2, y3 means, for example, patient 1, sugar is present, diabetes is present, yes 1. tumor is present 1, something next y3, if that particular COVID is not present 0, 1 shows present, 0 shows not present, means one patient having the number of Y's also. Y's means y1, y2, y3. Okay, we have just discussed about the x1, x2, x3 and only one y, but there may be a situation number of Y's are there, right? So in that cases, for example, prediction of the y3, we not require all parameters of x. For prediction of the y2, we not require all the parameters of x, right? So prediction of these things can be done with the specific features those are present in the data set, right? So dimensionality reduction is the next part. Dimensionality reduction is the same thing, that is a part of the feature selection. Whatever dimension is there, right, means raw data is there, we have to reduce that one with x1 and x2. By using that we have to predict a y, not required all things. That is a part of the dimensionality reduction. That is one of the important things. There is a many algorithms that can be used, right? So that dimensions are nothing but we can say that various kinds of features, and we have to reduce that one. We have to find the important features from that. Next. You heard, I think there is one lecture on that PCA also, principal component analysis. That is a part of these things. Dimensionality reduction. Whatever feature set is there, we have to reduce it. And there is some standard methods. By using that, we can find the principal component. Principal component means, for example, in institute there is one principal, means head. We can say that is one of the head, and that is an important component for that institute. So here also we have to find out one principal, means important component from the number of data set, so that can be used for the predictions of the y. Means, for example, sugar level is a principal component in diabetes. Okay, like this. So these kind of algorithms are used to find the principal components in the data set. Next, these are the various algorithms. Next. See, various methods are there. We are skipping both various kinds. But why these are the important? This is just a whole data set is there. We have to just find out the important components, and according to that, we have to focus on the algorithm and we have to focus on the y values. Time कैसा है? है नहीं time है? Here, this is all kind of feature engineering part. Okay. मी सांगतो आता बाकीच्या गोष्टी. हे theoretical part आहे बरोबर. See, important always we have to focus on the feature sets, right? Whatever problem is there, whatever data set is there, and whatever different kinds of variables are there, right? We have to focus on the selection of the parameters. These are the different methods. By using that, we can select the features, we can do the pre-processing on the data set, we can handle the missing values on the data set, right? So these kind of problems may occur anywhere, and we have to apply the various kinds of models are there. So in machine learning, we can't directly go for the feature engineering, or we can't go for the selection of the model, or we can't go for the selection of the feature also. These are the connected terms to each other. Means, for example, we have to check the model. It's depend on the last step of feature in machine learning also. Means, for example, whatever results are there, means whatever data set is there, if we apply a model on that, it produces the results, right? So that results are correct or not, that is one of the part. That is important things. Means, for example, a doctor uses a data set and it predicts the tumor. And according to the data set, the doctor applies a particular machine learning model and that model gives a brain tumor present. And if in the reality brain tumor is not present, right? Such a kind of situations are there. So how to take a decision and how we trust on a model, that is one of the part, right? So if initially we apply a model that gives something result as 80%, so always in machine learning there is a results like this, something 80%, 90%, 92%, 93% like this. And always there is a learning phase where we can improve the model, right? That model gives the, if model gives the better results, then we are focusing on that kind of models. So last part is that how these results are calculated, and that results are calculated by using the different kind of estimators. So there is a concept of estimation of the results, and that can be done by using whatever actual results are there and whatever predicted results are there. Means there is always training in the machine learning. Why that is? Because if actual results are there and predicted results are something different, then there is a gap. We can call it as an error, right? And we have to minimize that error. We have to minimize that error. Its meaning is we have to increase the accuracy. If we minimize the error, we can go for the increasing the accuracy, and that accuracy can be increased by using the various kinds of begin models. Means for example, if one model use 80 and second model use 90 results, we are going for the that 90, right? So such a kind of different model selection, and these things are depend on these error values also. So these estimators are important, and various kinds of estimators are there. Means for example, if we go for the classification algorithm, there is something different estimators. If we go for the clustering algorithms, there is a something different estimators, and those are used for the just evaluation of the algorithms. So evaluation of the algorithm is one of the important part in the machine learning, and if algorithms gives a better results, we can directly go for that kind of algorithms. So nowadays there is algorithms, some hybrid algorithms are there. Just try neural network algorithm with something SVM algorithm and try to find the results. If those results are best than simple SVM, then we can call it as a hybrid model and just use that model for the forecasting the future things. म्हणून बघा बऱ्याच रिसर्चमध्ये we are propose a hybrid model असे येते. Hybrid model is nothing but something mixing of two models, doing something in that models and predicting something future values, right? You can try. This is just a trial and error based system. Trial and error based system, we can call it as a machine learning. Whatever results getting from that algorithm, just try another algorithm and compare those results. So always any kind of data set is there and any kind of research papers are there. There is always use of different models and comparison between them. Always such kind of tables are present in those research papers by using SPM, by using something KNN, by using something neural network, by using CNN like this, and there is something different values are there. Because what happens, whatever algorithms used by one author with some data set, it may be possible same data set with same algorithms with same things, results may changes. Because if you train again and again, results are changing, right? So neural network is an important part in that cases also, because it gives towards the high accuracy. This machine learning has some of the limitations because it can't handle the image data, it can handle the large data sets, it can handle the number of features. Then there is a concept of neural network. Neural network, if you know number of layers are there, how it works, and then the combination of this neural network with something image processing is a part of deep learning. Then we are going towards the deep learning. So in that cases, you can use the image data sets, because in image there is a, we just see one example having the number of pixels, right? 8 lakh pixels are there, right? And if in your data set, image data set, there is a 1 lakh of images are present in data set, maybe a 10,000 images are present, and we have to extract brain tumor from each image, right? So what kind of operations are there? We require one image, we have to do number of calculation. 8 lakh calculation is we have to check each and every pixel in that table. It's meaning that require too much high performance computing. Now machine learning algorithms can done with simple systems, but for deep learning we require the high processing systems, number of CPUs, number of GPUs, right? So there is a tensor flow. By using that tensor flow, we can combine number of systems together. We can do or we can execute these all things over the cloud. Cloud is a one kind of combination of all things, where we can simultaneously use the processing power, storage power, and all another things. By using that, we can easily process the huge amount of data, and that can be done by the deep learning. What happens in machine learning? Simply we are writing y is equal to ax plus b. This is a simple equation, right? By using that equation, we can easily predict. This is a simple equation. But in deep learning, thousands of such kind of equation are used in a one model. In a one model. So you heard about the activation functions. These words, activation functions, means different kind of functions that can be handled by each neuron. Neuron is one of the a processing part that is using neural network, that is a part of the CNN also, right? So that neuron is a one kind of one equation that is present in machine learning. So machine learning is too much simple. All kind of algorithms can be executed with different equations only. But combination of these all number of equations is a part of the neural network. Because in neural network, whatever x are there is a first layer, second layer, number of equations are there, we can call it as a hidden layer, and lastly the whatever outputs are there. But in deep learning, the image processing part is also there and neural network part is also there. So it is too much in depth in the deep learning. So such a kind of data is increasing, so technology is increasing, and according to that algorithms are increasing. But machine learning are the too much simple algorithms. The basic important is the simple data sets are required, not handling too much high data sets. In that cases, we require to do this pre-processing part, we require to do various kinds of initial parts, then we have to apply the model, we have to use the visualization, we have to use the feature selection, algorithm selection, various kinds of methods in that. And we have to check the estimators, and by using that estimators, we can easily find which model is best or not for the predicting the data sets. So we are concluding here. And if you have a question, you can ask any about the machine learning. I can give any kind of answer from my view.
Sir, how neural network works in machine learning?
Sir asked a good question, right? How neural network works in a machine learning. I just told that AI is a one part. It contains machine learning, it contains neural network, it contains deep learning, and many more technologies, right? So machine learning simply is what y is equal to x plus c. This is simple example. We can call it as a machine learning. In these cases, there is a three important parts. Initially, I told just two, x and y, but there is a something different part is there. That part we can call it as a coefficients. What is called as a coefficients. So, for example, see y is equal to 2x. Simple example. That equation is a like this. Okay, that line equation is a like this. If y is equal to 3x, that equation is a like this. If y is equal to 4x, means that line is changing with the equation, because all of you know that line having the specific equations. So that specific equation is changing with what, x and y or something coefficient. It's changing with the coefficient, not with the x and y. X and y are always the same, but line equation changes with the coefficients, means that 3, 4, 5, like this. Means, for example, if my data point is like this and my equation showing this one, this is not a good thing, right? But data set is like this, so I move the line equation like this, so it gives a correct results. This is situation, right? So how that line is shifted? That is shifted with the change in the equation, right? And if we change the coefficient, then and then equation changes. So that coefficient is an important part in the machine learning. Similarly, in neural network, there is a part of the weight and bias. These two values are present, weight and bias. So there is also x is a fixed part and y is a fixed part. There are the different layers are there. We can call it as an initial layer, then middle layer, and last one is something last layer we can call it as. Okay. So for example, initially x is given, right? There is a something function x1 plus x2. x2 is also there, x3 is also there. These are the inputs. We can call it as a various kinds of features. Okay. So first operation is x1 plus x2 plus x3. Like this operation is there. Something x2 plus x3 like this also operation is there. But our aim is what? Our aim is to correct results, and we have to go for that results. Means for example, y is equal to 1. If we set y is equal to 1, and that model gives result as a 90. Which model? Y is equal to 3x plus 2. That is the equation present in neural network. It gives the values at something 9 or maybe 0.9 for example. Now we have to change these values, parameters. According to that, y value changes. Correct? Always, whatever data set is there, if we change the coefficient, y always changes. So changing of these things is important. And if how many times it will be changed? If y is equal to 1, then stop. If y is equal to 1, then stop, else change it. And what to change? We have to change that coefficients. This kind of situation present in neural network. Means we have to initially give the weight and bias table to the equation, and according to that, what is y? If y is not satisfactory, change the weight and bias. So such kind of things are present in neural network, and aim is y is equal to 1, its meaning result is the correct one. Till that we have to train the model, means we have to train the same model that is present in machine learning, y is equal to x plus b, but that can be trained with the number of neurons. By using that we can easily predict the future things. Means each neuron is one kind of equation in neural network. Yes?
So, gradient desensitization.
Radial descent is one kind of optimization algorithm. That is something different. It's not any kind of, we can call it as a classification algorithm. Always there is a classification and clustering algorithms are there. But aim is what? Optimization is what? Always we have to work on coefficients also. Whatever coefficients, justly I say that if we changing these coefficients, then equation will be changed. So we have to focus on one optimal condition where we can stop changing of these coefficients. So that is one of the algorithms that can be useful for the managing the coefficients. That is related to the managing the coefficients. So if we manage the perfect coefficients, its meaning is we are the best in the equation, and that will predict the best future things. Similarly in SVM also. In SVM there is a simple equation. Same equation is equal to, is used. For example, x plus b is equal to y. Right, like this. So there is a case plus 1 and minus 1. There is a different hyperplanes. By using that we have to test various, means depending upon the various kinds of equation, we can apply the various kinds of models on the data sets. So it's totally depend on the equations. Yes. Anyone? दुपारचा सेशन आहे त्यामुळं येस एनी क्वेश्चन सर मी सांगितलेलं काही कळालं असेल तर नाहीतर काय ठीक आहे थँक्यू